So having seen that model view controller is kind of the gross organization of these apps, let's actually take a look in a little bit of detail, but not too much, at each one of the three pieces, starting with the models. And we'll touch a little bit on databases and ActiveRecord. When we continue later on with your first Rails application and stuff like that, we'll see these topics in more detail. The goal here is to introduce them so that you know how these buzzwords and concepts sort of fit into the big picture. So going back to our kind of view of the world here, this is where we are. We're going to talk about models. And both the application server and the database or persistence tier are responsible for managing the parts of your code that have to do with models. So the fundamental problem that the persistence tier has to solve in any SaaS app is that in your code, there's objects that you operate on in memory. So if you've been playing around with IRB, you've been seeing that if you print out what's the value of this variable, typically you'll see something like this pound notation showing what class the object belongs to and some ID for that object. And then you can ask about properties of the object. But when it comes time to store that thing persistently, you've got to somehow figure out a format in which you can freeze dry it, put it into persistent storage, and then get it back when you need it. And depending on which language you're using and what decade you were born in, some people call it marshalling, some people call it serializing. Other people don't call it that at all. They just figure that's how it works. And then unmarshalling or deserializing is getting the thing out of storage and reconstituting it in memory so that even though its object ID is now different, right, you've kind of synthesized a new object, it behaves in all the same ways that the original one behaved. So how do you get seamlessly back and forth between these two kinds of representations? And again, as you might expect, this is such a common thing that all SaaS apps need to do that a number of different patterns or frameworks have evolved to help solve this problem. The basic operations that all of them kind of have to support is what's called the Crud Operations: create new objects, read objects that already exist, update properties of objects that already exist, or delete objects and incinerate them forever. And in the ActiveRecord design pattern, which we will be using, ActiveRecord is distinguished by the fact that every model knows how to CRUD itself. And there's a set of common mechanisms that all ActiveRecord models share so that when you say, I want a new thing which is a movie and it's got these attributes, you don't have to worry about when it's time to marshal the movie, what are the specific steps to essentially package that whole thing up and put it in the database, and what are the steps to unmarshal it and come back out. So let's have sort of databases 001. In Rails, the most common paradigm is to store all of your models in relational databases. If you've taken a class or have some background knowledge of relational databases, that's great. If not, here's the 5% that will get you halfway to the 10% that you need to know. Relational databases store things in tables. Each type of model gets its own table in the database, and basically one row in a table is one instance of the model. So in a movies table, each row of the database will represent one movie object that we want to store. The columns in the table store the value of model attributes. So every movie has a rating, a title, a release date, and that means that in every row the structure is the same, right? We can't in general decide that some movies are going to have titles but other ones aren't. Well, we can do that, but in terms of the database, as far as it's concerned, every item is the same. Any variation from that would be up to us to handle on our own. In addition, in a relational database, every row has to have some unique value that can identify that row called the primary key. And by convention, in Rails, this is an integer. It's called the ID. Generally, you don't have to deal with it because Rails will automatically create and assign new IDs for you, but be aware that it's there. So in practice, you would very rarely care what the ID of a movie is. All the information about the movie that matters is in the other columns. But you need to have a way to uniquely reference it in case, for example, there's duplication in the other columns. That's what the ID does. OK, so again, this is the 5%. The 1% maybe in today's meme terminology. But since architecture is about alternatives, whenever I say this is the way it's done in Rails or this is the way it's done in SaaS, you should immediately be thinking, well, what other ways could it be done? Which alternatives were left on the table? And there's actually a fair amount of contention about the pros and cons of ActiveRecord as a pattern. Oh, sorry, I should point out, a schema is, generally speaking, it's the collection of all tables in a given database and what their structure is. So if you see the word schema, that's what it means. OK, so what if we didn't use ActiveRecord? And when I said every model knows how to CRUD itself, well, doesn't that seem kind of obvious? How else would you do it? Well, here's another way you could do it. I've sort of used a bastardized version of the UML, Unified Markup Language, which we'll learn more about shortly, to try to illustrate the difference between ActiveRecord and Data Mapper, which is another very popular way to do this. So here's the idea, right? It seems trivial, but in ActiveRecord, we just say, oh, we've got these two models, movie and moviegoer, and each model has built-in knowledge without us having to do anything in our own app code about how to interact with the database to do the 4 CRUD operations. Whereas, in the data mapper pattern, for each model that we create, we also have to set up a mapper for that model that has specific instructions on what it means to do the CRUD operations for each model type. And in fact, whereas ActiveRecord pretty much has to run on top of a relational database, which we'll talk more about shortly, data mapper can run on top of almost anything. So you might ask, well, why would you want to do this one way or the other? One reason is that, as we mentioned a few minutes ago, relational databases are really hard to scale, especially past a certain point. But there's a lot of storage engines that aren't relational that scale extremely well. So there's some benefit to structuring your data in a way that you could use those underlying storage engines. And in fact, Google App Engine does this, right? If you write an app that runs on Google App Engine, in general, you can't write relational database queries. There are some cheats you can do, and there's some nice features they provide to kind of make it look like you sort of can in some simple cases. But generally speaking, you cannot. On the other hand, because their storage engine is much simpler, it scales unbelievably well. And there's data mapper libraries that you can use to help you decide how you're going to take each of your models and store it in their database. But what's the downside to doing this? When we looked at our model view controller diagram just a few minutes ago, we saw that models can have interactions among each other. For example, a review can sort of be associated with a particular movie and also associated with the person who wrote it. Or if we were going to do voting on movies, you could imagine that a movie has a bunch of different rankings, and a ranking is associated with that movie, but with a particular user, right? So there's going to be one-to-one, many-to-one, many-to-many relationships. As we'll see, there's mechanisms in relational databases that are set up exactly to try to represent those associations and to make it easier for your code to traverse them, right? So given a movie, who are all the people that gave it 4 stars or more, or 4 potatoes or more? Unfortunately, those exact same mechanisms, although they make it very easy to write complicated queries, are exactly the things that can bite you if you're not careful when it comes to scalability. So therein lies the trade-off. ActiveRecord takes advantage of these more sophisticated features of relational databases to make it easier for you to express complex relationships and write queries about them. But the price you pay is that scalability becomes a challenge. On the other hand, data mapper makes you do all of that work yourself, right? If you want to associate moviegoers and movies, you have to write some specific logic about how they're going to coordinate, and you have to do manually a lot of the kind of work that would be done for you in a relational database. But what you get in exchange is scalability is awesome, because each individual model has a very narrow relationship to the storage engine, right? So again, we'll revisit this when we talk about associations under advanced Rails, but my goal is to never sort of present a concept without also presenting what the alternatives are and why one alternative might have come out on top of the others.